Okay, hello. I hope everything is all right. So I created your quiz. I posted your quiz scores. So check that one. So you should have your scores for your quiz and quiz number 1 and for your assignments. So check those. If you have any difficulty or anything is missing, just email me so I can correct it. So what we are going to do, the next target is going to be your test. Okay, test number 1. I think it's on March 3rd. We can check it to make sure it's all right. So we are going to continue. We're going to take chapter 2. It's very important, but not a difficult one. So in chapter 2, we are going to introduce a kind of new functions. So a matrix, we are familiar with the matrix operations, okay? Adding, subtracting, multiplying, and eventually we talk about the inverse of a matrix, and we apply the inverse in order to solve a system of the equation. Some of you use determinant in order to find the inverse of a matrix in question, I think that was question number 1. So you didn't get the full grade because this is the topics that we're going to see in this chapter. So we ask you to find the inverse using that inversion method, okay? So correct it. I will post the solution for your quiz too. So correct it because you are going to see it on your test. The test would cover 11 questions. 5 questions would come from the quiz number 1. So correct your mistakes, and because we won't get time to review that part again. So correct your mistakes, make sure you are familiar with the topics that we covered, and then we need 6 new problems, and that would come from okay, from a couple of sections that we check, I think number 7, 1.7, 1.9, and just make sure you are okay, you are fine. So check your quiz and make sure you know that it's compared to my solution so that you're not going to miss any point. And some of it did very well, very good one. Okay, so what's going to be in this chapter? We are going to assign a new number to a given matrix, a kind of new function, which is going to be very, very important and very useful. So if a function is given to you, we assign a number to that. If a matrix is given to you, so we are going to assign a number to that matrix, and that number is going to be called a determinant. And it's happened to be a very useful one, okay? So we're going to check this one. Not bad. There are a couple of procedures that we have to get through it, but eventually it's a very good one. It's going to be very, very useful for future, okay? So let's see, just slowly getting the first preliminaries. There is a section 1 and 2, some property of determinant, and in section 3 is the crunch. We're going to see the property of determinant, and eventually that gives us a new method to solve a system of the equation. So on the test, you got to be careful. And we are going to give you the name of the method, then you go for it. So far, the method that you did was just a method of elimination, and we're going to see some determinant, some application of determinant solving the system of the equation. It's kind of algebraic method. Okay, but by itself is going to be interesting. So let's go and check, give you some idea of the notion of the famous notion of the determinant. Okay, and this is the format that was given by Arthur Cayley, and later on was applied by more British mathematicians for all of them. Okay, so this is going to be 2.1. Again, I don't know why we get these with this camera when we get to your class. Okay, so we switch it. We should get back to the, yes, that's it. We got it. So it's a 2.1, 2.1, and the idea is what is the determinants of a matrix. Okay, so what is going to be the determinants of a matrix? There are different ways to define the determinant of a matrix. So we get it step by step, and this is going to be a full version. So we go for the first part. If we be just giving okay, a one by one matrix, if you like, see if the matrix A would be just containing one entries. You have to define all of them inductively, if you like. Okay, so that's going to be just a matrix is going to be is a kind of by one by one matrix. Okay, it's a one by one matrix. The determinant. Okay, the determinant. The determinant of A is going to be denoted by, we're going to use two different notation. Okay, denoted by, the first notation is just det of A, which is very popular, the determinant of A, or what we are going to do, which is kind of like absolute value. So it's like, okay, to vertical line. So this also means the determinant. Okay, and is going to be defined, for this one, we have nothing but the, okay, just one interest. So it's going to be the determinant of A or det of A, which is going to be the same thing, this same notation. So in this case, this is going to be A11. Okay, it's very rare, but we have to define everything. So that we are done with the one by one. Okay, so we go to the 2 by 2. If you have a 2 by 2 matrix, okay, so if A is going to be, this is going to be our matrix. So for example, if this is going to be A11, then A12, and this is going to be A21 and the A22. Okay, so this is going to be the matrix. Then the determinant would be defined. We already talked about it, but we didn't mention it. So then the determinant, okay, then the determinant of, okay, determinant of this matrix of A is going to be defined by, okay, this is it. This is going to be defined by, this is it, the det of A, okay, is equal to, sometimes we use this notation for a matrix, just remind you, if we use this notation, it means determinant. Okay, so the determinant, I just want to introduce this notation. It's going to be kind of cross multiplication. Okay, it's going to be cross multiplication. Okay, we multiply these two together. Okay, and these two. So it's going to be A11. Okay, this is it, A11, A22. This is it, 1122 minus the other way around. The other way around is going to be A12 and the A21. So that would be our definition for a 2 by 2 matrix. Okay, kind of cross multiplication. So that would be a 2 by 2 matrix. We are going to configure the 3 by 3, and then we give a formula for all of them. Okay, so we talk about it inductively. Inductively means a step by step. We build up the first failure, then we go to the second failure, the third, the fourth, etc. So what are we going to do by, if we get a 3 by 3? If we have a 3 by 3, we reduce it into a 2 by 2. Then we can take care of it. Okay, so if we have, okay, if A is going to be, if A is going to be a 3 by 3 matrix, a 3 by 3 matrix, okay, this is what would happen. So what we're going to do is, this is going to be the determinant of the A. If you want to find the determinant of the A, so this is going to be the determinant, the notation that we're going to use. So the matrix is going to be A11, A12, A13. Then we get to the A21, A22, and the A23. Then we come back here and we get the A31, A32, and the A33. So you want to find the determinant of this matrix. So what we're going to do, we are going to reduce it into 2 by 2. The way we're going to reduce it, we are going to eliminate one row and the one column. You see, we are going to delete, if you like, the first row and the first column. Okay, so we delete this one, then this is going to be equal to the first term. You see, the first term is going to be A11. Okay, A11 now. A11, the position of the 11 is the first row, first column. So we eliminate the first row and the first column and multiply by the determinant of the leftover. The leftover is a 2 by 2 matrix. So it's going to be times, okay, it's going to be times it by A22, okay, A22, A23, and this is going to be A32 and the A33. Okay, so that's going to be the first part. Then we go with the second one. Then we use a negative sign here. Okay, it's going to be negative. The second term is going to be 1, 2. 1, 2 means we are in the first row, second column. So we eliminate the first row and the second column. You see, this is going to be the first row and the second column. If you eliminate the second column, the leftover is going to be, you see, this is going to be the leftover. The leftover is going to be a 2 by 2 matrix. It's going to be A21. Okay, A21, A23, A23, and this is going to be A31, A31, and the A33. Okay, so we go to the second term, A12, and we continue. Now it's going to be plus the third term that we have over here is going to be A13. Okay, this is going to be A13. A13 means you are in the first row and the third column. So what we're going to do, we are going to eliminate the first row and the third column this time. Okay, eliminate the third column. So the leftover is going to be, A1, A21, okay, A22, and then this is going to be A31 and the A32. Okay, so we say we expanded along the first row. We can do all the other rows too, but this is just the beginning. So we expanded about the first one. So A11, A11, delete the first row, first column, so the determinant of the result matrix. Then you go to the A12, but use a negative sign, positive, negative, positive. Okay, this is going to be A12, eliminate the first row, the second, so that would be your matrix. Then we go to the third one, is A13, the first row, the third column out, so that give you the result. Okay, now this is just a 3 by 3. We want to make up a new formula so that we be able to extend it for other terms. So we are going to use a special notation. You see, let's see how did we get this one. You see, we get this one by eliminating the first row and the first column. So that's why we are going to call this one, okay, this determinant, we denote it by the determinant of a matrix of A11. A11 means a matrix that resulted from eliminating the first row and the first column. What is this one? You see, this is A12. So this is going to be the determinant of the A12, okay? And what is going to be this one? This is going to be A13. You see, as you can see, 1, 1, 1. That stands for the first row because you did start with the first row. If you start with the second row, that formula would be different. So what's going to be the determinant so far? So the determinant of the A now, it's easier to memorize it. It's going to be A11. Okay, so this is going to be A11, the determinant of a matrix of 1, 1. Okay, this is going to be minus. Then we get the A12, the determinant of a matrix. Okay, A12. And then this is going to be plus. Okay, this is going to be plus A13. A13, the matrix is going to be A13. Okay, so we eliminate, we go along the first row. So that's why we get 1, 1, 1, 1, 1. You can go with the second one. You can go with the third one, whichever you feel more comfortable, if you like. Okay, now we are going to have some notation for these ideas that we put over here. Okay, so the notation that we are going to use, you see, look at these numbers. The number that we have, you see this one, this determinant, this plus this negative sign. And over here, these numbers are going to be called cofactors. Okay, so the numbers, so all new terms. The numbers, okay, this is going to be the case. So the numbers, the determinant of the A11, okay, negative A12, and this last one, you see these are going to be all the coefficients of these A11, A12, and A13. So these are going to be called, okay, the expressions are going to be cofactors. Okay, so it's going to be cofactors. Okay, cofactors of the first one of the term A11. Okay, for the second one, the terms A12. And for the third one, the terms is going to be A1, A13. Okay, these are going to be cofactors and are going to be denoted by, and the notation that we're going to use, and are denoted by, okay, denoted by, we go with the C for the cofactor. Okay, so this is it. We have C11 is a cofactor of the A11. So that gives you this number. Okay, that is going to be the first one. Then the second one, you have a C12. Okay, C12, which is going to be negative the determinant of the A13. Okay, then we get the last one is going to be C13. C13, which is going to be what? So the C13 in this case is going to be A13. Okay, what's the advantage? The advantage is going to be, we can write easy formula for the determinant. So note that what is going to be the determinant of the A now? The determinant of the A is going to be A11, A11, C11. You see? Plus A12, C12. Okay, plus A13, A13, and C13. You see, you can expand the metrics along their cofactors. You see, they are all one, start with one, because we just distribute it along the first row. You can do it with the second row, the third row, you know, it doesn't matter. In general, all of them are going to be the same thing. Okay, and where is or what is these numbers that we have? And these numbers, we already talked about it. Okay, so the numbers are going to be, okay, the numbers are going to be the determinant of these matrices. So some of them are positive, some of them are negative. It depends, you see, it depends on the row and the column. We're going to get the formula. You see this 1 plus 1 would be 2, so this is positive. 1 plus 3, sorry, this must be 2. Okay, this must be 2. This is 2. 1 and 2 would be 3. Is the odd number, if you like. This is negative. And then 1 and 3 would be 4, which is going to be even number. We are going to write down the formula generally, and then you will see this is going to be positive, negative, positive, negative. Okay, so this is going to be the case. And again, you can say that where, if you like, you see, where, if you want to find the Cij, you see Cij, means the cofactor of the aij. So there's going to be a sign. So it's going to be negative to the I plus j. Okay, the sum of this row and the column. And then we get the determinant of the aij. You see, if you get a 1, 1, 1 plus 1 would be 2, so negative 1 squared would be positive. If you get a 1, 2, 1, 2, 1 plus 2 would be 3, negative to the third power would be negative. And over here, if you get 1 and 3, 1 plus 3 would be 4, so that gives you a positive, okay, a positive number to get these numbers. So this is going to be nicely written in terms of the cofactors. We have another formula, okay, related to this one. Okay, so this is it. We have, you see, we just carry these with the signs and we call it cofactors. If you drop the sign, just pick the numbers. They are going to call minors. Okay, and you know, this is just the beginning. You must know these expressions and knowing these formulas. The numbers, just to finish that preliminary definition. So these numbers, okay, the numbers, this is just the determinant without any signs. Okay, the number determinant of A11, okay, determinant of A1, okay, A12, okay, and the determinant of A13. These numbers are called minors, okay, are called, okay, these are going to be called minors. This is it, minors. Because, you know, some problems they ask for it, and so we are ready for it. Minors of, okay, these are going to be minors of this the entries A11, A12, and A1, A13. Okay, so this is it. So we usually write the notation that we're going to use. We write the minors, okay, Mij. This is going to be just the determinant of Aij. So this means you just delete the I rows and the j column and find the determinant of the resulted matrix, okay? So this is going to be the case. So in fact, if you like, note that, you see, this is going to be the case. So we can use this notation if you like. You see the Cij, the cofactor of Aij is going to be -1 to the I plus j times Mij, okay? This is going to be, you know, different way to write it down to get these numbers. Okay, so you find those determinant without any signs, they are going to be minors. But if you consider the signs, it depends on the number, okay, where the position is, okay, the I for the I row and the j column, then you may have a positive or the negative one. Okay, so basically, these are going to be the cofactors. So to finish it, if you like, so the conclusion is going to be, so the conclusion of this argument that we start is that if we have a n by n matrix, you see, if A is, okay, is an n by n matrix, okay, matrix, then we can define the determinant of this matrix, the determinant of the A. You see, you pick one row and you distribute it. Okay, depends which one do you want. Okay, the first row, the second row, you know, whichever row you are going to be interested in. Okay, if you just pick the first row, for example, you see the first row is going to be the first row, okay, and suppose the first row and the j column. So is going to be, say you get A1J, A1J times the cofactor, C1J is the first row, J column. So this is going to be, okay, you just continue. This is going to be A2J. You fix the column, okay? And this is going to be C2J. And then you continue. Okay, you continue, get to the 1, 2, 3, 4, 5, 6 to the end. So it's going to be ANJ, ANJ, CNJ. Okay, so this is going to be one version, if you like. So what I did, I get you see, this is going to be, if you like, this is the matrix that you have. Okay, this is going to be a matrix. So your matrix start with the A11, A12 up to the A1N. Okay, somewhere is going to be AI1, AI2 up to the AIN, and this is it. So you go to this is AN, okay, AN1, AN2, and eventually we get to the AN, okay, ANN. This is going to be a matrix, okay? So somewhere here is going to be the J column. So this is going to be 1J, this is going to be 2J, and this is going to be NJ. So what we do is, in general, you can get, you see, you can get this, you eliminate this row and this column. Okay, then you can write your determinant, if you like, to get what I did for this formula. I just eliminate the first row and the J column over here. Okay, the first row and the J column. So I extended along along the first row. You can do it along the I row. It doesn't matter. Okay, so you have to fix it. So for example, if you want to go with this one, okay, if you want to go with this one, so the determinant is going to be what? So I pick the I row. So it's going to be I first column. So that's going to be CI1. Okay, then I2, then CI2. Okay, so I just continue to get this one. Okay, so it's going to be these are going to be the terms that we're going to have, and then we continue to get the okay, this is it. It's going to be 1. So over here, just eliminate. Okay, you are going to eliminate the I row. You see, this is going to be the I row, and sorry, this must be J. So this is going to be CI, CIJ, I1, I2 up to the okay, this is it, up to the IN times the CIN, if you like. Okay, these are going to be the case A1, 2, 3, 4, 6, etc. So different format that we can have for the determinant. Give you an example, then we identify what is going on. Okay, so it depends on which row and the column you want to distribute it to get the one. So over here I did for the first row, and over here I did it for the I did it for the I row, if you like. This is going to be the one. I just get the I1, AI1, AI2, AI3 up to the to the last one, and then you have to bring the cofactors to get to the last one. Let's give an example to see how we are going to do these type of problems. So there are a kind of 3 types of the problem that are going to be given. Example, let's start with the easy one. We want to find the determinant of this matrix. Find the determinant. 3 by 3 is easy, really. We can do it as is, not big deal. Determinant of each matrix. There are some shortcuts, but we don't need it. Okay, so I just do this one generally without any formula to see what's going on. So that's going to be 2, 3, 4, 2, 3, 4, 5, 6, okay, 5, 6, 7, and this is going to be 8, 9, 1. Okay, so I just do this one generally. It's not a big deal, so we can do it right away. Say this one, solution. So what I want to do is I want to find the determinant of A. I just distribute it over the first row. Okay, so it's going to be 2. It's going to be 2, eliminate the first row and the first column. So the resulted matrix is going to be 6, 7, 9, 1. It's minus, okay, positive, negative, positive. So it's going to be 3. Eliminate the first row, second column. So it's going to be 5, 7, 8, 1. Okay, and 4. Eliminate the first row and the last column. So that give you 5, 6, 8, 9. Okay, I'm just doing generally. It's not a difficult one. We can simplify it, but it's not a big deal, so we go right away. Okay, so I distribute along the first row 2, eliminate, delete the first row, the first column, 6, 7, 9, 1. Positive, negative, 3. Just do the same thing, 5, 7, 8, 1. Then a positive 4, 5, 6, 8, 9. Now there are a 2 by 2. We can do it right away. So this is it. So the determinant of A is going to be equal to, this is 2, cross multiply, 6 times 1 is 6, minus 9 times, okay, that gives us 63, minus 3, 5 times 1 is 5, minus 56, plus 4, 5 times 9, 45, minus 48. Okay, quickly we can get the result. So this is going to be what? It's going to be 2 times negative, okay, negative 57. 57, this is going to be minus 3 times negative 51, and this is going to be 4 times negative 3. So the result is going to be negative 114 plus 1, okay. So what is going to be this one? Just double check this one. It's going to be 5, okay, minus 56, okay. That's correct, and giving me 157, and this is going to be minus 12, okay. And just check this one. Yes, that's okay. So what we are going to have is going to be just that give us okay, that 114 and 12. So it's going to be, what's that? It's going to be negative 128. Okay, 126, 126, 153. And if you subtract it, the result is going to be, okay, 7 and 3, 2. So that give you, the determinant would be 27. Okay, not a big deal to start with. Okay, most of the time we have a 3 by 3. Then we are going to have some other method, easy method to simplify it. That's type 1. Okay. Type 2, they are going to be more specific. You see the type 2 problem. You have quite a lot in your book. And we give you one on your next test. They give you this one, okay? Suppose a matrix is given to you. This is going to be a 4 by 4 matrix, and this is 2, 3, -1, 1, and then you have a -3, 2, 0, 3, and we have the 3, -2, 1, 0, and the last one is 3, -2, 1, 4. Okay, so this is a given matrix. Okay, now then they ask for just some quantities. Okay, this is it. They want you to find the following. They want you to find what is going to be M32 and C32, cofactor and the minors. And a part B, they ask for M24, okay, M24 and C24. Okay, we just check to see if you are familiar with this notation. Okay, remember this is M32 means you are going to eliminate the third row and the second column, and then you find the determinant of the resultant matrix. When you find it, this is without any signs, then you bring the signs to get the cofactors. So this is going to be the same thing. Okay, so this is the way we're going to do it. Solution, the first part. The first part, you want to find what? You want to find M32. M32 means the determinant of this matrix, A32. So eliminate the first row, you see this is it, the first row and the second column. The second column, the leftover, you find the determinant of the leftover. So the leftover is going to be 2, -1, 1, -3, 0, 3, and the last part is going to be 3, 1, 4. This is going to be the resultant matrix. Okay, you find the determinant of this one quickly and you're done. So it's going to be 2 times, eliminate the first row, first column, 0 minus 3. 0, 0 times 4, 0 minus 3. Next one is going to be negative, and this is also a negative. So eliminate the first row, second column, -3 times 4 is going to be -12 minus 3 times 3 would be 9. Okay, that's the one. Then plus 1. Eliminate, okay, this is it, the first row, third column. It's going to be -3 times 1 would be -3 minus 0 times 3, which is 0. That's it. So that gives you what this is going to be 2 times -3. Okay, negative, positive, plus inside that give you -21. And this would be just a positive. Okay, this is 1 times a -3. So the result is going to be -6, and -6, -21, -3. The answer would be -30. Okay, so -30 would be what? Would be M32 is a -30. Okay, negative M32 means eliminate the third row and the second column. Now the cofactor, you just consider the sign, -1 to the 3 plus 2, okay? So that was M32, -30. So the corresponding cofactor is going to be, this is it. So the cofactor of the 32 is -1 to the 3 plus 2 times M32. So -1, 3 plus 2 would be 5, negative M32. So it's going to be negative. They see M32 was 30, -30, -30. The answer would be 30. So the cofactor C32 would be equal to the 30 with that. Okay, so not a big deal, but important property. We said we need to find all of them when we get to the next section. Okay, so that's the part one. The part two. Part two, they ask for the M24. Okay, M24. So you have to eliminate. You see, this is it. M24. You have to find the determinant of the A24. You are going to delete the second row, the fourth column. Okay, if you do it, the leftover is going to be this matrix. It's going to be second row, third column. Second row, third column. This is it, 2, 3, 2, 3, 1. Okay, it's 2, 3, 1. Then we have just get the matrix. So I eliminate the second. Okay, the second row and the fourth column. So this is it. I don't have the second row, so I have the third one. Okay, this is going to be 3, negative 2, 1. Okay, and then I have the 3, negative 2, 1. Again, both of them are going to be the same. Okay, so I delete the second row, and the fourth column. Second row and the fourth column. Now I can find this determinant right away. So there you are. So M24, I distribute it along the first row is going to be 2. You see, negative 2 minus, it's going to be negative 2. So make it to positive. Okay, this is going to be the result. Then it's a minus 3. Delete the first row, second column. So that give me 3. It's going to be minus 3. And this is going to be plus. Okay, first row, last column is going to be negative 6. Okay, 1 times negative 6 minus negative 6, that give you positive 6. So it would be 0 because all of them are going to be 0. Okay, this is going to be 0, 0, and 0. So M24 is equal to the 0. And the C24 is the same thing. So C24 is negative 1 to the 2 plus 4. Okay, M24, which is equal to the 0. So be ready for it. They may ask for all the cofactors. So we should be able, to put them together and give us the final answer. Okay, so you can distribute the matrix along any row or any column, just using these cofactors that we talk about it to get your result. So I'm going to give another one. Sometimes it's good to pick a good one, good row, but the answer to all of them are going to be the same thing. So let's check to see what is going to be the advantage if you have something nice. Okay, you have some in your book. That's why I wanted to know it. So we want to find the delta of A. Find the determinant of this matrix. What is the matrix? I'm going to give you a 5 by 5. So should have enough place for it. It's going to be this is it. This is the matrix A is equal to it's a 5 by 5. So it's going to be 3, 2. 3, 2, 0, 1, 1, 3. Okay, then we have a negative 2, 4, negative 2, 4, 1, 2, 1. And then we have a 0, 0, negative 1, 0, 1, negative 5. Okay, and we have a negative 1, negative 1, 2, 0, negative 1, and 2. And then we have a 0, 0, 0, 0, 2. You see, this is going to be your matrix. Okay, remember, you can distribute it. You can find the determinant, distribute along any row or any column, and using the corresponding cofactors. Look at this one. You see the fifth row, all the entries are 0. So if you distribute along the fifth row, that lots of them terms would be 0, and then you'll be able to find the result right away. Okay, so officially, you don't have to, but I write it down so that you know it. You see the solution is going to be, I want to find the determinant of the A. So what I'm going to do, I'm going to distribute it along the, okay, along the this row, the fifth row. Okay, so in fact, my terms are going to be, you see the first term, the fifth rows are going to be, you don't have to write it down. I'll just write this one so that to show you. It's a fifth row is going to be 5, 1. Okay, the fifth row column 1. So this is going to be C 5, 1. And then you just continue. It's going to be 5, 2. Just keep going. C 5, 2. Then you go with the 5, 3. 5, 3. C 5, 3. Then you go with this A, okay, A 5, 4. C 5, 4. And eventually we get to the A 5, 5. C 5, 5. You see, I can distribute along any row. You see, we talk about it. You can pick any one you like, you know, along the J that this is the first row, this is the J row, if you like. Okay. Now, as you can see over here, what is the advantage? The advantage is, you see, this is A51 is 0. Okay, A52, 0. A53, 0. A54 is 0. So your determinant basically is going to be what? Your determinant would be just this one. Okay, it's A55, A55, C55, which is simply is going to be equal to what? A55, this is going to be the A55 is equal to 2. So that would be 2. Now what is C55? C55 is negative 1 to the, okay, negative 1 to the 5 plus 5. 5 plus 5. And the determinant of which matrix? The matrix is going to be, okay, so in this case, you eliminate the first row and the first column. I write it down, then I'm going to evaluate it. It's going to be A55. Okay, this is going to be negative 1 to the 10. Okay, negative 1 to the 10 would be just a positive 1. So that would be 2. So what I can do is, so this is going to be in fact 2 times A55. So A55, you eliminate these two. So the determinant is going to be, this is going to be your leftover. The leftover is going to be 3, 2, 3, 2, 0, 1. Okay, it's going to be a 4 by 4 matrix. And this is going to be negative 2, 4, negative 2, 4, 1, 2. Okay, and this is going to be 0, negative 1, 0, 1. And then you have a negative 1, 2, 0, negative 1. Okay, so this is going to be a 4 by 4 matrix because you are going to eliminate the fifth row, and the fifth column. Then you can work, you can work on this one to check to see which one is going to be easier. I explained the other one, so I can do this one quickly. Look at this one. Look at this one. So if you distribute it along this column, all the terms are 0 except this one. So now you know how to do it. You see, originally you have the 2. You read this one, which is going to be, what term is it? You see, this is going to be, is a negative 1. Okay, negative 1 to what? And what is going to be the place? The place is going to be the third row. Okay, so it's going to be the third row plus which column, and this is it. Sorry, this is the second row, 2, second row and the third column, second row and the third column. Okay, and the entry is just 1. So the entry is 1. So how about the matrix? Your matrix is going to be what? This is it. And so you are going to find the determinant of A23. Okay, and so simply A23. So what is going to be A23? Negative 1 to the, this is going to be negative to the fifth. Okay, that give you negative, so that give you a negative 2. Negative 2 times the determinant of a 3 by 3 matrix. So it's going to be negative 2. What's going to be the resultant matrix? 2, 3. So you eliminate the first, the second row, and the third column. So the matrix is going to be a 3 by 3 one. Okay, eliminate the second row, third column. So what's going to be the resultant matrix? Is going to be 3, 2, 1, 3, 2, 1, 0, negative 1, 1, then the negative 1, 2, negative 1. You see? So if you pick something nice, it enables you to get to the result more quickly. And this is easy matrix. Okay, you can distribute it and get the determinant right away. Okay, you can distribute along the second row if you like, and get the result right away, or just ordinary one. It doesn't matter. You can distribute it along the first row to get the final answer. The determinant of the inside one is going to be 6, or the negative 6, and then you multiply it. I'm going to write down for you. Okay, so it's good to be able to pick a nice one, especially when the size is going to be a big size. So that will help you. So I'm going to distribute this one to show you that it's going to be easy. So I just go with the ordinary one. So it's a negative 2. Okay, it's a negative 2 outside, and start multiplying. Okay, distribute it along the first row. You see 3, 2, 1, or the second row, doesn't matter because it's a 3 by 3. So it's the first row is going to be 3. I write it down because I don't have it on the other side. So negative 1, 2, 2, negative 1. So that's the first one. It's minus 2, minus 2. Okay, that gives you 0, 1. It's a 0. Okay, that's going to be 0, 1, negative 1, negative 1. And the last part is going to be plus. Okay, the last part is going to be plus. And you have a 0, negative 1, negative 1, and 2. Okay, easy to find. It's a negative 2 times. Okay, negative 2 times. It's going to be 3 times. You see, this is a positive 1 minus 2. And this is going to be minus 2. This is going to be 0, 0 minus, which is going to be plus 1. And it's plus 0 minus, and this is just 1. So the result is going to be negative 2 times, it's a negative 3, it's a negative 2, and this is going to be just a negative 1. Okay. So as I told you, it's going to be negative 2 times a negative 6, which is a positive 12. So the determinant of a matrix is going to be 12. Okay, so most of the determinant that we're going to use and to evaluate for us is going to be an easy one, but you have a couple of them in your book. So you better pick a nice, nice row or nice column to be able to take care of it, quickly. Okay. So I have another one. I just quickly explain this one too. Okay. So probably similar to your problem that I make a note. So again, we want to find the determinant of this matrix. Okay, find the det of A. What is this matrix? It's a 4 by 4. So this is it. You have 1, negative 2, 3, 0, 0, and then you have a negative 1, 1, 0, and you have 2. And then you have a 0, 2, 0, 2, 0, 3. Okay, 0, 2, 0, 3. And what else we have? We have a 3, 4, 0, negative 2. You see, just look at this matrix. It's a 4 by 4. Try to simplify it. You see, you reduce it to the 3 by 3 quickly. Pick the right row and the column. You see, look at this one. In this column, everything is 0 except 3. So you are going to expand it along this column. You see, that's going to be the 1. So you are going to have only what? This is it. So this is going to be the first row and the third column. Everything else is 0. Okay, so the solution is going to be simply the determinant of A is going to be. Okay, you have only one terms. Okay, so this is going to be your case. This term is, I write it down for you. It says the term is the first row and the third column, and this would be times your cofactor. That's it. C13. Okay, because you are going to pick here, everything else is going to be equal to the 0. So easily you can find it. So this is going to be A13, which is equal to 3. Your cofactor would be -1 to the 1 plus 3. And the minors, which is going to be determinant of a matrix of A13. That's it. -1 to the 4th would be positive, so that gives it 3 only. The resulted determinant, 3 by 3, you are going to eliminate the first row and the third column. The leftover is going to be simply, okay. So this is going to be the case. We eliminate the first row and the third column. So the result is going to be what? Is a -1. Okay, the first row would eliminate. So 1, 2, 0, 2, 3, and the 3, 4, and the -2. You see? Nicely done. Okay, and next one you can do it as usual, or just pick this row to to distribute it to get your final answer. Okay, so if you like, you can go with this one, which is easy. So you have the 3 and you are going to distribute it. So this would be 0, nothing. So we get -2. We are going to eliminate the what? Eliminate the second column, second row, second column. So the determinant would be -1, 2. Okay, and 3 and -2. Okay, so I eliminate the second row, second column. So only we get this one. Okay, so which is going to be +3 times eliminate the second column, the third, the second row, third column. So that gives -1, 1, 3, 4. See, can be done easily. It's going to be 3. Okay, times this is a -2, cross multiply. So that gives it 2 minus 6 plus 3, cross multiply. So that gives it -4 minus -3. So what's going to be the result? It's going to be 3. It's a -4. -4 times -2 would be 8. And this is going to be -7. So that gives -21. -21. So so that was a negative, positive, and everything's all right. So it's going to be 3 times, 3 times, and we get the negative, is it 13? Yes, 13. So the result seems to be determinant of the A is going to be -39. I didn't miss any sign. Okay, double check to make sure everything is all right. Okay, so what we did have a positive 3 from there. Okay, positive 3, we distributed along here. So that's the first time with this up here, everything else would be 0. So this is the, on the, okay, that's going to be, this is the second row. Okay, the second row and the second, second row, second column. So it's second, this must be positive. Okay, this would be positive. Okay, that's the give you a positive 1. Okay, because this is the one, you see that's do it along this one, so we get to this part. This is going to be the second row. Okay, this is the second row, second column. So we get 2 plus 2, which is 4. Sorry, this would be positive. Okay, then what is this one? And this one is a stand on the second row and the third column. This must be negative. Remember, anytime the cofactors, remember, Cij is negative 1 to the I plus j, I plus j, and this is Mij. So as you move on, if it's going to be the first row is positive, negative, positive. If it's going to be any other row or any other column, so when we get to the sign, you have to check, you see, that is the second row, second column. 2 plus 2 would be 4. Negative to the 4 would be positive. When we get to this part, this is going to be second. Okay, this is going to be the second row, third. 2 plus 3 would be 5. So negative 1 to the 5 would be negative. So this is going to be positive, and this is going to be negative. Because I was sure that this must be, okay, a positive. So let's see what we get so far. So this is now is going to be negative. Okay, because we get the 2 minus 4. And now this is going to be positive. So that give you a positive 39. The final answer must be positive 39. Okay, so be careful when you distribute it along any other column or okay, any other column, and just make sure to get the sign of the cofactors all right. Okay, negative 1 to the I plus j, Mij. Negative 1 to the I plus j. So if it's going to be the first row, automatically give you those positive, negative sign. But for the others, it is not going to be the case. That's it. Introduction to the determinant first section. The first section is all computational. Okay, we didn't use any theorem. Okay, we just take it as is. So what we can do in the second section, I want to give you just time a little bit just to think about it, and I post the next one maybe tomorrow again. So get the feeling, okay, how we're going to distribute this, take care of the determinant. But when we get to the second section, we just check the property of the determinant. That will help us to simplify it. For example, we can use row echelon form if you like to reduce the matrix first and then get the determinant. You got to be careful. There are some options, some operation that would be all right to do it, but some operation are not. So that's why we should be careful. Okay, so that's the definition of the determinant. So basically, really, this is what we have. So inductively, we define it. Okay, the 2 by 2 is just those cross multiplication. For the 3 by 3, the idea is you can eliminate one row and the one column. So you reduce it to the 2 by 2. So that gives an idea of how we're going to do it in general. Okay, for the general one, we are going to get these resulted matrices that we call it cofactors. Okay, so that will enable us, easier to remember that you want to find the determinant, you pick one row or one column, you distribute it. You put the entries first, then the cofactors. It's going to be same index, so C11. This means you eliminate the first row and the first column, you reduce the matrix. This is the starting was 2 by 2, so 3 by 3, that would be 2 by 2. And then you get those numbers and you put them together, okay? So just put them in this format, so it's optional. We can do any row, any column. That's why the determinant of a matrix and the determinant of its transpose are going to be the same. Okay, and just some examples. So check the example of this one. Tomorrow I'll take the 2.2, a little bit more technical, but quite interesting, some property of it. Okay, have a good one and take care. Okay, just read this one quickly so that we get to the 2. Okay, I put something for you, 2.2 and the 2.3. We try to finish this chapter by the end of this week. Okay, have a good one. Take care. Any question on your quiz, just email me, let me know. If anything is missing, let me know quickly. Bye-bye.